Hi, I'm Ms. Cho, and in this video we'll use long division to divide polynomials. Let's start with a refresher on vocabulary. When we have a division problem, it can be sideways, it can be vertical, or it can be in the long division house. Regardless of what form it takes, the number that you start with in blue is your dividend. The number that you're dividing by in yellow is your divisor. The answer that you get in green is your quotient. And whatever you have left over in red is your remainder. You can either write your remainder as R3 or as a fraction 3 divided by your divisor, or 7. Let's review how long division works. When we do long division, we follow 4 main steps. We want to know how many times our divisor will go into our dividend. And so I start with 7. Can 7 go into 1? No, it can't. So I move on to the next place. Can 7 go into 15? Yes, it goes 2 times. So then I multiply the 2 times the 7, which gives me 14. I subtract, which gives me 1. And then I bring down to 2, and I start over. 7 goes into 12 one time, which I multiply, which to give me 7. I subtract to give me 5, and then I bring down the 2 for 52, and I start again. 7 goes into 52 7 times, and 7 times 7 is 49. I subtract, it gives me 3, and then there's nothing more to bring down, so my remainder is 3, which I'm going to write as a fraction 3 divided by 7. We can do the same exact thing with polynomials. In this example, we're asked to use long division to find the quotient and remainder of 2x squared plus 15x plus 20 divided by x plus 6. Our numerator is our dividend, and our denominator is our divisor, so then I'll just set up the house accordingly. I've also written my symbols on the side to remind me of my steps. First, I want to look at how many times x plus 6 can go into 2x squared. I'm really going to focus on my highest exponent, so I want to know how many times x goes into 2x squared. Well, it goes 2x, so if I multiply 2x times x, I get 2x squared. 2x times 6 is 12x. And so I've done my division and my multiplication, and I'm going to subtract. I'm left with 3x here, and I bring down my 20. And then I start again. How many times does x go into 3x? It goes 3 times. 3 times x is 3x. 3 times 6 is 18. And then I subtract. And that leaves me with 2. I have nothing else to bring down, so then my remainder is 2. And I'm going to write this as a fraction over my divisor, which is x plus 6. And this is positive. If I want to know if I've done this correctly, I can multiply it back out. So to check, I'm going to use the box method to multiply out my divisor, my x plus 6 times my quotient and remainder 2x plus 3 plus 2 over x plus 6. When I multiply 2x times x, I get 2x squared. 3 times x is 3x. This fraction is 2 times x over x plus 6. And my second row, 2x times 6 is 12x. My 3 times 6 is 18, and then this fraction is 2 times 6, or 12, over x plus 6. I'm going to collect my like terms. 2x squared doesn't have any, but 12x and 3x are, and then my fractions are like terms. So 12x plus 3x gives me 15x, and then I have 18, and then because my fractions have the same denominator, I'm just going to rewrite all over 1, and I have 2x plus 12 on top. I notice that 2x and 12 are both even, so I can factor out a 2. And when I do that, I get 2 times x plus 6 over x plus 6, and my x plus 6's cancel, leaving me with 2x squared plus 15x plus 18 plus 2. Now my 18 and my 2 are like terms, and I can combine them as 20, which is exactly the starting polynomial, or our dividend. If you're not comfortable with multiplying this out, you can also graph the left side and the right side and see if they match. In Desmos, I've graphed my dividend as my red one, and my divisor and my quotient and remainder as my blue graph. As I toggle my blue graph on and off, I can see that it is exactly on top of my red one, so that means I've divided correctly.